All right, hope you're doing well. Here is Unit 6, Topic 5. This is dilations. And really, just to kind of get us started, a dilation is really just taking a shape and making it larger or making it smaller. Angles stay the exact same, angle measures stay the exact same, so that's really the idea here. So if we look at this example, you'll see that there's several different triangles that are sketched on there. Here's what we started with, were the blue coordinates. And then our first objective was, it said down here to multiply those coordinates by 2. So essentially double it, and then to see what that looks like. So if if we take a look, here's a starting point, here's a starting point, here's a starting point. So if we wanted to double that, and here was the center, this is 1, 2 units to the left. So if I double it, I'd have to go another 1, 2 units to the left, which puts me here at A prime. Another way that we went through this was we said, all right, you could count the slope. So 1, 2, 3, 4 up and 1 to the right. And so if I did that once, I've got to do it a second time. 1, 2, 3, 4 up and 1 to the right, which puts me then at B prime. Same type of deal here, down 1, 2, 3, 4 and 1, 2, 3, 4 to the right. So down 1, 2, 3, 4, 1, 2, 3, 4 to the right. That's doubled. That puts me at C prime. To find that green triangle, it told us down there to multiply by 1/2. So if I think about, well, to get to A was 2, half of 2, that means I only go left 1 as opposed to left 2. To get to B, if you remember, we just went up 4 and right 1. Well, half of 4 is 2, so I'm going to go up 2, and half of 1 is a half, so I only went over here half of a unit. To get to C double prime right here, we would have gone down 4, but I'm going to do half of that, down 2. And then instead of going right 4, I'm going to go right 2, which puts me there at C double prime. So that's kind of how we generated those values. You could use the idea of slope, which is really useful as you're enlarging and as you're reducing in size. Let me scroll down a little bit. We just listed the coordinates there, so you can look back up top and check that out. But essentially, when the scale factor is something that's larger than 1, you'll notice that the shape is going to increase in size, or the side lengths are going to increase. And then if it's getting smaller, if it's between 0 and 1, it's a reduction in size. And so those side lengths are getting smaller. All right, so let's go to the next page. Right up here, a dilation. It's a transformation that produces an image that is the same shape as the original, but it is a different size. So I used the example in the classroom. I think you had the projector there on the ceiling. And so if this was the bulb of the projector and then I put my hand in front of it, you could see the shadow that's produced on the board behind my hand. And then, we talked about this shadow is going to be larger than what my hand is. So as the light, passes over the hand, it creates that shadow behind it that's actually larger than what the actual size of my hand is. So this would be something that's an enlargement. Um, and then we talked about, just some other different real life examples, but that's one. Even if you had a flashlight, you shined it, and then the shadow that produces behind it's going to be larger. Those types of things are some good real life examples. All right, so let's scroll down here a little bit more. And we'll look at these two examples. All right, so it says find the scale factor, the dilation centered at the origin below. So if I think about this, in purple here, we went up 2 and left 1, and I went up 2 and left 1 again, and that was to get to B prime. So to get to B, I had to go up 2 and left 1, and then I had to double that, or I had to do it again, so the scale factor would be 2. It's one way in which you could do it. The other thing, if you remember from that first page down there, it had us multiply the coordinates. And so if you looked at the coordinate for B, here's the coordinate, and then if you noticed, how did I get from 1 to 2, from 2 to 4? Each of those values is multiplied by 2. That's another way in which you could come up with that value. All right, let's look at this example down here. They give us this original shape, and then it says use a scale factor of 3. So if I count up 1, 2, 3, and I go right 1, That's how I get to m. So to get to m prime, I'd have to go up 1, 2, 3, and write 1. That would be doubled, but I need to triple it. 1, 2, 3, and write 1 a third time gets me to m prime. And that's what we did to get to n. That's doubled, that's tripled. O, that's doubled, that's tripled. And then for p, that's doubled and that's tripled. That's how we found those specific locations. And then it wanted to know what's the distance of MN right here. So we used a little Pythagorean theorem. So we kind of pulled that little triangle out that was sketched. 1 squared plus 2 squared gives me 5. Take the square root of that. So this is the square root of 5. That's what this length was if you were to measure it. The square root of 5 units. And then it says, without performing the distance formula, what would that distance have to be for m prime, n prime? Well, if I've multiplied by 3 and use that as my scale factor, it should be 3 times the square root of 5. And then we actually did justify that. If you look up here, down 1 and right 2, so that's a square root of 5. Down 1 and right 2, that's a square root of 5. Down 1 and right 2 more, that's a square root of 5. So we actually had 3 square root of 5s right up there. And then you'll notice this little root 10. That's because we went down 1 and then 1, 2, 3 to the right. So 1 squared is 1, 3 squared is 9, so this gives us the square root of 10. So if I went down 1 and then 1, 2, 3, this would be a square root of 10. In here, we didn't have it labeled. And then down 1 and 1, 2, 3 to the right, that's also a square root of 10. So there was one of them, and then it was doubled, so you'll notice there's 2 square root of 10s. So you could write that as 2 root 10. Didn't ask about it in that problem, but just another good opportunity there to kind of tie that in. All right. A few more examples here. So the scale factor is 2. All right, so let me see if I can switch to a different color this time. All right, so here was the starting point. We've already overlapped, but if I went up 1, 2, 3, 4, and I go left 1, I'd have to double it. So 1, 2, 3, 4, and left 1 again puts me at A prime. In this case, 1, 2, 3, 4, 5, and right 2, up 5, and right 2 puts me at B double prime. And this point right here does not change because that was the center point. And let's see if this is our last example. Yep, looks like this is the last example from the notes right down here. And for this one, here's your center. Scale factor is 3. So I'm going to go down 1, 2, 3. I didn't have to move left or right, so I'm going to just go down 3 again. 1, 2, 3. This would be doubled. Down 1, 2, 3. That's tripled. So this is the location that I'm looking for right here. In this case, 1, 2, 3, 4 to the left. Didn't have to move up or down. So 1, 2, 3, 4 to the left again. That's doubled. 1, 2, 3, 4 to the left. That's now tripled. So that's the location that I'm looking for. And then C, down 3, left 4, down 1, 2, 3, left 1, 2, 3, 4. That's doubled. 1, 2, 3 down, and 1, 2, 3, 4 to the left. That's tripled. So that's how we then can construct that red triangle. This yellow one in here, this gold one, that would be doubled with a scale factor of 2. All right, so scale factor of 2 and then scale factor of 3. That just really gives you a good idea of how, as that value gets larger, how you see that shape appear to get larger as well. If we wanted to, we could throw one on here that was a 1/2. We didn't do that, but half of 3 would be 1.5. So I'd have a point right in here. And then half of 4 is 2. And then this would be, instead of going down 3 and left 4, down 1.5 and left 2. So this would be then created with a scale factor of 1/2. All right. And you could do a 1/4, a 1/3, a lot of different options there. 1/2 is just kind of a common one that we see quite a bit of, but that gives you one where now, when you think in terms of here's the original shape compared to where the center is, it's getting closer to that center point, which is going to reduce the size of each of those sides with comparison to those other examples. You'll notice as you're scrolling through there, at least in that PDF that I sent out, you've got quite a few examples that you can work through there on the dilation. So plenty of stuff there to try to get comfortable with that process.